C2, Trigonometry, Section 1, Example 7. So here we're asked to sketch graphs of the following functions. So the first one is so y equals 4 cos x. And we can tell from above here, we have this f of x going on. So that means that we have a stretch scale factor a in the y direction. So I've got my x-axis and I have my y-axis. And the shape of the curve doesn't change, so we still start at the top, come down and back up, but this time instead of going between 1 and -1, it's going to go between 4 and -4, but we're still going to cross our axes in the same place. So this will still be 90 degrees, this will be 180 degrees, this will be 270 degrees, and this will be 360 degrees. So that's part A. Sorry, we're not doing our measurements in degrees, we're doing them in radians. So this will be pi over 2, this will be pi, this will be 3 pi over 2, and this here will be 2 pi. So that's part A done. So now for part B, we need to sketch the graph of y equals sine of 2x. So this time we have this, which is a stretch scale factor 1 over a parallel to the x-axis. So I'm going to have my axes again. So y and x, and this time we have a stretch of scale factor 1 over 2 in the x direction. So it's a bit wonky, but we're going up to 1 and down to -1. But this time here we're at 90 degrees. Here we're at 180 degrees. Here we're at 270 degrees. And here we're at 360 degrees. So as you can see, instead of just going up at the top for 90 and then back down for 180, that all happens in a period of 90 degrees this time. So for part C, we are asked to draw y equals tan of x plus 45 in a period of -180 degrees to 360 degrees. So that means that we have this, which is a translation of -a, which means that we move to the left. So need to have some negative axis this time. So the important thing with tan is where the asymptotes go. So now, because we have moved the graph, the asymptote that's at -90 degrees will now be at -135 degrees. The asymptote that's usually at 90 degrees will now be at 45 degrees. And the asymptote that's usually at 270 degrees will now be at 225 degrees. Okay. So now we need to draw our graph. Which will come up from there. Then start at the bottom. Cross over to there. and again, like that. So that means usually we would cross our x-axis for the first time at 0, but now we're crossing it minus 45 degrees. Here, usually that would be at 180 degrees, but now it's at 135 degrees. So that's about as much information as we need on the graph, except for we would have a cross in the axis here, which would happen at 315 degrees. So now, moving on to part C, we're asked to draw minus sine of x plus pi over 6. So this time we have a translation of minus a over 0, which means that we're moving to the left, but also we have y equals minus f of x, which is a reflection in the x-axis. So we have a reflection and a translation happening at the same time. So, draw my axes. So this time we have a period of minus 2 pi to 2 pi. So we end up with a graph that looks a bit like this. I ended up running out of room, so I'll try that again. So I've given myself a bit more space this time. Up to 1. Back down, so we just cross the axis at minus pi over 6. Back down to minus 1. Up through 5 pi over 6. And we'll cross our axis again at 11 pi over 6. So I'll put them measurements on. So we cross, instead of crossing the axis at 0, we're at minus pi over 6, remembering that we have a reflection in the x-axis as well. So that's why instead of starting up at what, instead of going up first, we went down first. And here we have minus 7 pi over 6 instead of crossing at pi, minus pi, sorry. And then instead of crossing at pi here, we cross again at 5 pi over 6, sorry. And then here we would cross again at 11 pi over 6. Still going down to minus 1 and still going up to 1, but we've had a reflection and a translation occur at the same time.